So what we're going to do on the next page is there's the directions. We have this data table that you're going to be filling in. So what it says first is size of sediment. At each location, the students are required to identify the size of the biggest piece you see. All the photos have rulers in the pictures, so students can estimate the sizes. The smallest divisions on the rulers are in millimeters. How do you estimate the size of the grain that's smaller than a millimeter? Imagine lining up the number of grains and counting how many are needed to make a millimeter. For example, if it takes 8 grains for 1 millimeter, then the average grain size is 1/8 of a millimeter, and you could do 1 divided by 8 on your calculator and get 1.25 millimeters. So let's go over how to do just the size. So we're going to look at the pictures. We're going to choose the biggest particle we can find and use the clear ruler and measure it in millimeters. Then we're going to look at the table where it says size of sediment and choose whether it was a boulder, a cobble, pebble, gravel, sand, or silt. We're going to think about how fast the water must have been flowing to carry that piece and how much energy the water had. So on our table, the very first site number 1, is Cataract, and it was 0.32 kilometers from the source, and it was very steep. And the way we know that is if we go up here, we can look at the waterfall, which is the cataract, and it was very steep. So coming down here, we need to fill in all of these green boxes. So we need to measure the grain size, the sediment size, how fast the water is flowing, and how much energy we think the water has. If you click on the names of these, it'll actually take you straight to where the information is. So this is a picture of the rocks that were collected at the cataract or the waterfall. So it says, general picture, all the large pieces are rock fragments. Be sure to include these as you estimate percentages. Oh, so if all the large pieces are rock fragments, we're going to estimate that all of these big ones that we can see are rock fragments. To me, that looks like maybe almost 90 or 95%. So I'm going to say 95% of them are rock fragments. So I'm going to go back up to here, and when I'm estimating the percentages, I'm going to put 95% of these right here were rock fragments. Now I need quartz and feldspar. So let's go back down here, and we're estimating the grain size. So we need to pick, in this picture, the biggest piece we can find, which looks like this one, and we're estimating how long it is. Now, a little bit is cut off, but I'm going to imagine it ends right here. And remember, each mark on the ruler is 1 millimeter. So if I take my mouse and I say, okay, that's 1 millimeter, that's 2, that's 3, 4, 5, 6, 7, 8. I'm going to say that rock fragment, the biggest one, was 8 millimeters long. So I'm going to go back up to my data table, and right here where it says measure the largest grain size, I'm going to say that that was 8 millimeters long. Now for sediment size, boulder, cobble, pebble, gravel, sand, and silt, I'm going to go back up here and I'm going to look and see what would fit 8 millimeters. So let's see. Gravel is 2 to 4 millimeters. A pebble is 4 to 64. So 8 millimeters would fit right in between 4 and 64 millimeters. So when I go back here, I'm going to say that this was a pebble, was the largest one. Since I know that the waterfall or the cataract was very steep, I'm going to say the water was fast. And how much energy the water had, well, if the water is moving very fast off a waterfall, it's going to have lots of energy. Now, I said that it was 95% rock fragments, and then I need to estimate the quartz and the feldspar, and I need to describe the rock texture and color. So I'm going to go back to here and click on it to go straight to the cataract. Let's see. So if most of these are rock fragments, 95%, oh, I see a lot of quartz. And I remember it's quartz because I can see the light coming through. So if 95% of these are rock fragments, I'm going to say most of the rest is quartz. Maybe 5% is quartz, but there's a few I can't see through. So I'm going to say that 4% is quartz and 1% is feldspar. So I'm going to go right here and I'm going to say 4% was quartz and 1% is feldspar. What colors do I see and what textures do I see? Okay, so going back down here, all the rock fragments, I can't really see through these. And so I'm going to say that most of them are dark, but for the quartz, I can see through and I see a lot of tan, some kind of orange or cream. Now, when I look at these rock fragments, especially if I look at this picture, the rocks look really sharp. They're kind of jagged. They're not really smoothed over yet. So right up here in my description for site 1, I'm going to say for colors, I see dark, cream, tan, and then some of them are clear. And then for texture, I'm going to say that they're sharp, jagged. So now I have completed the cataract one, and I'm going to leave this one for you all so that you all don't have to fill this in, but you have it as an example for when you're doing your own. So what you're going to be doing is you're going to go through the next ones and you're going to be filling in what you would estimate the biggest rock size was at site 2, site 3, site 4, site 5, and site 6. Now, when you're doing that, you can click on this and it'll just jump and take you straight to the forks, or you can just scroll through the rest of the document to get to the rest of the sites. On the last day, so by next Wednesday, your goal is to answer this final conclusion, and this will really wrap together everything that you've learned. So the goal is actually to write 5 paragraphs, 10 to 15 sentences, and you're comparing the most common grain size to the steepness and water flow. And there's 3 sites. So you're going to discuss the cataract, the waterfall, Bishop Park, and then 1 site in between these 2. So right here, these are the 5 parts of what you're going to be doing. And as you can see, they've already been laid out for you, except you still have to choose which site you want to use for your middle site. Also, to get you started, there's some sentence starters right here that you can choose from. So for a thesis statement, it says, grain size, what happened to it, as the distance from the source increased and the stream flattened out. So I'm going to say grain size, and then I'm going to put either increased, or you could write decreased, as the distance from the source increased and the stream flattened out. So really the biggest thing you have to choose here is whether you think that the size of the sediment got bigger, whether we saw bigger particles coming down the stream, or whether we saw smaller particles coming down the stream, and that's what you're going to put right here. Now we're describing the cataract site. So it's asking what was the most common grain size, how far it was from the source, whether it was big, medium, or small, whether the water speed was fast, medium, or slow, and whether the water had lots or just a little of energy. So on my cataract site, I'm going to say, I think that maybe even though I saw a pebble, gravel was probably the most common grain size. So I'm going to say gravel was the most common grain size, though I did see a few pebbles. This site was, okay, so now it says this site was blank kilometers from the source. So if I don't remember, I'm going to go back up to my data table where it says site 1 cataract. Oh, here it is. It was 0.32 kilometers from the source. And I can even copy that and paste it right here from the source. Okay, so let's see what we have now. So we have what the most common grain size was, how far it was from the source. The next thing it says is the grain size was big, medium, or small because the water speed was fast, medium, or slow. So I found that really big rocks were mostly at the cataract site far up. So I'm going to say the grain size was big because the water, let me think, if it was a waterfall, it was probably moving fast. So the water was moving fast. Okay, and then it said, and the water had lots of energy. Okay, so I'm going to put the water had lots of energy to carry big sediment. So you'll write a paragraph like that for the cataract site, Then you're going to choose a middle site. So when you go back up here, you could choose Forks or Bitterbush, Plant 5, or Walton Park, any of those sites to describe. And then the last one you're going to describe is what happened at Bishop Park. So once you describe those, then you'll write your conclusion, which there's some sentences down here. So you could say, as our data show, grain size, and you could say whether increased or decreased or stayed the same. Bishop Creek flowed farther from the source. This is because what happened to the steepness. So what happened, I'm going to put the stream became less steep for the water, and then thinking about, was it flowing faster or slower? So once you finish this conclusion, this is really showing everything that you learned from the lab, both the evidence and the relationships you're drawing from it. Because if you remember, if we go back up here, our main goal for the lab is that you figure out what's the relationship between how fast the stream is flowing, the size of the sediment, and the minerals that we find in these sediments. So the other thing I could add actually up here in cataract site is the minerals were mostly rock fragments and some quartz. So that's about it. Let me know if you all have questions. I'd be happy to help you, and I'm looking forward to seeing what you all learned from this.